My name is Steve Rahi. I am a Premier Field Engineer specializing in System Center technologies. Today's discussion is part 13 of an ongoing series discussing operating system deployment in ConfigMgr 2012. Today, little attempt at humor in the title, to be known or to be unknown. That is the question. Really, what we're going to talk about today, focus on those two items. In ConfigMgr, in operating system deployment, a system will either be known or it will be unknown as we target it for deployment. Understanding the detail behind both of those items and how they can operate, some of the challenges or differences between them is important. So want to spend some time on that. Here's our agenda. The format of this discussion will be more discussion-centric than a lot of these. Most of the time in the other sessions we spend in demo, certainly there will be some of that here. But these are more or less concepts, and so understanding those concepts, talking through some things about those concepts is what we're on tap to do today. So introduction, talk about known or unknown, kind of definitions, go into details about configuring, working with, and then benefits and challenges of known and unknown. So let's talk about what known and unknown really are first. So we've talked about a lot of different things as we've gone along through this series, different scenarios that we would support, you know, the bare metal imaging scenario, the reimage scenario, thick versus thin imaging, on we go, right? Well, this is just another concept to kind of put in the back of your mind, well, not in your back of your mind, the forefront of your mind, to understand, make decisions about, plan accordingly. So by definition, an unknown computer is one that is not known to the ConfigMgr environment, meaning it is not in the database. If there's no record about it, it has never been in ConfigMgr, at least it isn't in ConfigMgr right now, right? A very common scenario would be purchasing machines from a manufacturer, getting a bunch on the dock and plugging them in and wanting to start imaging them. Certainly, you know, we can do that. It is called unknown computer support. The contrast to that is known computer support, which means that there is a record in the ConfigMgr database of this machine. One that you can know because it's in the database is a machine that you care about, right? So a little bit of trivia, looking back on OSD in previous versions of ConfigMgr, we started, when we first introduced ConfigMgr 2007, we started this new flavor of OSD by not allowing any unknown computer support. The reason for that really was seen as a security thing. It was considered more secure to, and it is more secure, to not allow unknown computers, right? More on that in a little bit, but in just, the real issue is, in some scenarios, some easier than others for sure, if you have someone that walks into your business or somehow connects to your business network, they could, in theory, in practice, obtain an image from your environment containing proprietary things, maybe whatever's in your image, right? Without any restriction, right? So unknown computers were kind of taken off the table initially because of that. Well, as we went along, there was demand for it, and so we brought it back, and we've made it in a way that it can be done safely, but there are some things you need to understand about it, right? And then I have this little graphic down here. ConfigMgr supports unknown computers, basically a statement with a big red X on it. Yes, we do, right? That's the text to the right. Okay, true, but not really. We do support unknown computers, otherwise I wouldn't have spent the time to talk about it. You know that we support unknown computers. But the reality of the real point here, probably splitting hairs a little bit, we don't image a system that we don't know. We don't image a system that we can't target, is another way to say it. Now, we may not know about this new system that's being turned on and plugged into the network and we're going to image. True enough. So that's why it's splitting hairs. But the point is, in ConfigMgr, in order to accommodate the unknown computer's need, we actually created a placeholder, if you will, records that can be substituted. So if you turn on unknown computer support, more on that in the next slide, and if you have a system that is not in the ConfigMgr database, and if you have a task sequence targeted to an unknown computer, not necessarily the collection, an unknown computer, then that we match, architecture, site, whatever, we will allow imaging of that machine. But it's because we substitute the unknown record, and you'll see that as we go along through here a little bit, right? So yes, we do, for all practical purposes, in very obvious ways, support unknown computer. The mechanics of it a little bit different, right? And you'll see that. All right, so in terms of configuring known versus unknown computer support, known is our default. There is no configuration really necessary for this. In fact, unknown can be turned on as well. It's default in some cases. You really need to, I say must specifically enable, need to think about it for sure. Before you turn it on, you do need to do some enablement work. I mean, it's nothing really different than known in terms of targeting collections, knowing where to put things and different things. But be aware of that. So in terms of a demo, let me just show you real quick the places where we can configure unknown computer support. So first of all, in my task sequence, down here, in my task sequence node, I have the ability to create task sequence media. Well, there's an option here, bootable media, that I can walk through, and we'll very quickly see. I'll just click through this. Create a dummy entry. We'll quickly see this page, and you'll notice enable unknown computer support is turned on. So is the password, right? This for sure, the password is something I always turn off because of testing. Consider that, for production, whether you might want to leverage it. Not part of the discussion today. Kind of will inject a couple of places, but anyway. And then here, enable unknown computer support. If you turn this off, then we will restrict your ability to image an unknown system with this particular boot media we're going to create. All right. Now, in addition, so this is through boot media. In addition, you can enable Pixie to support unknown computers. So let's go there real quick. Distribution point. Pixie tab, and you'll see here as well, we are allowing unknown computer support, right? So that's there by default. You can take it off if you don't want to allow that. Now, so pretty simple, pretty easy from there. The rest of this is standard OSD kind of terminology, things that you'll need to understand in order to make the right choice about what to do, right? So let's talk about working with unknown systems first. So when we look at unknown systems, right, we will group all of our unknown systems into a collection called all unknown computers by default. That is a default system collection. So we'll dig into that a little bit in a second. But first, the whole idea of unknown computers, the very scenario for this is seen when we're trying to deploy new computers, as mentioned, ones that aren't in the ConfigMgr database, ones that you don't want to put the work into to stage them all in the ConfigMgr database, maybe don't have the data for it, whatever. Or it could be repurposed systems that have an existing operating system, but you don't want to take advantage of that. You want to treat them just like they're bare metal, right? And that's a point here. In unknown computer imaging, you must always treat systems as bare metal. There is no other choice. In order for there to be another choice, such as a reimage type scenario, the system would have to be in the ConfigMgr database, so you could deploy a task sequence to it in the running OS and launch it from there, right? You can't do that in an unknown computer scenario. Yeah, you can do some hoops and do some external things to approximate it, but strictly, you can't do it, right? Through all-in-one through OSD. Now, what do I mean? Huge tangent that you can approximate it. Well, if you wanted to take the steps to pre-collect the user state and collect data off the machines like computer names and so on and store them away, and then have an unknown computer task sequence launch on that bare metal machine when it boots bare metal and use those things you've stored off, that's possible. Very easy to do, or well, conceptually easy to do. Right? And that's one of the beautiful things about OSD is the flexibility that you can bring to whatever your imaging need might be, especially after you understand how the options work how they fit together, and so on, right? So, point, the machine, oh, sorry, before I go on to the next point. So here's a question, and I want to spend some time on this. I'm going to pull the lab back in, right here, and look at the all unknown computers collection. Here it is, right? And if I look at it, you'll see that I have 6 records for unknown computers. I have actually 4 from one site that I really should have 2 in. There's some skeletons in there from some testing. This is my lab after all. But the point is, you have 2 records, one for each architecture, x86 and x64, per site, per primary site, right? So what is the purpose of this unknown computers collection? Like any collection, it's for grouping things that you want to have in this collection. In this case, we're going to pull in all of our unknown computers into this collection. Now you can use this, you can target task sequences against this, no problem, and then all of your unknown computers across all of your sites will be able to run the task sequences targeted against the all unknown computers collection. That's very common. But here's a question, what I'll show you when we get to the demo. You notice that there are records, 2 records from each site, 4 in my case, for 1. And so are you limited to only targeting to the unknown, all unknown computers collection, and then having all of your unknown computers treated the same? The answer is thought sometimes to be yes, but it's really no, right? There is some flexibility here. It's not as flexible as a known scenario, as we'll get into, but here's the point. These unknown computers are site specific. One of the questions I ask is there really any benefit to creating a custom collection and putting unknown computers in that custom collection? The answer could be yes, right? Because you may want to have some sort of unique imaging for your unknown computers at a specific site. You may want to have different imaging for unknown computers at a single site. You may have a different image scenario for your x86 systems at site A, and then a different imaging scenario task sequence for your, what did I say first, x64, whatever, the other architecture at your site, right? That is very possible. These are systems, in quotes, very much like a real system. They have the identifiers that will let them hook up in the same way. Here's the limit. For every architecture item at a site, so for the x86 unknown computer at a site, everything that you target to that x86 unknown computer system will be visible by anyone imaging an unknown x86. Doesn't matter how many collections you put it in, it's still the same object that will be targeted for the task sequence, right? Another way to say it, whenever you boot an unknown x86 computer, even if you have that unknown record, x86 record, in 5 collections, and each one has a different task sequence, you're going to see all 5 task sequences because it's a combination of the task sequences targeted at the machine, right? Hope that makes sense. All right, so probably it'll be helpful to see that in demo. We'll do that in a minute. So let me pull the lab back out. So in terms of unknown, we've already said it. Unknown systems, they have to be unknown. As you add new systems into the environment, they will automatically be unknown unless you take some action to pre-populate the database. Then those systems by default will be unknown, right? If you have existing systems, those repurposed pieces of hardware that you want to treat as if they're unknown, you're going to have to make provision to remove any records about those systems from the database. If you leave those records in, then those machines will be known, and all of your imaging through unknown for those machines won't work, right? Okay. Image systems become known systems. Pretty obvious point. Whenever you image a machine, at the end of the imaging process, you want that machine, you need that machine to be a ConfigMgr client and show up in the database. And so once you image it, it is known. That does raise an interesting scenario though, because if you ever want to treat that machine as an unknown computer, again, bare metal image it, you're going to have to remove it from the database. Otherwise, you'll be blocked, and it won't do an unknown type image, right? It won't get that far. Keep this in the back of your mind as we get to the demo, and I'll show you some of this, right? Another thing that comes up, certainly I could go through a laundry list of things here, but a common thing that comes up with unknown is the idea of planning for a computer name, right? So with any imaging that happens, remember, anything that happens in OSD, all of it, when you image a machine, it's a fresh load of that OS. Even if you start in the running OS, we're going to store away some variables that we collect in the running OS before we reboot. Once we reboot into PE, we're wiping the disk and loading on a fresh operating system, right? While we're in PE, that computer name will be mini-nt, right? That's the default for Windows PE. Not a very friendly name that you want to carry forward into your production environment. So if you want to change the computer name of an unknown image system, you need a way to do it, right? There are different ways that you can actually make the adjustment to the computer name, but there's one variable. It's called OSD Computer Name. In OSD Computer Name, if you set that variable, again, you can set it a couple of different ways. I'll mention them here in a minute. Once you set it, then once we reboot into Windows, once we image, once we reboot into Windows, then OSD Computer Name takes effect and the system will be named appropriately, right? If you're in a known scenario, contrasting, then we will scrape the computer name of the machine before we reboot, store it in variables, and can preserve that as we go forward. So it will be the same name at the end, right? Or you can change it, whatever, right? Flexibility here. But just be aware of that so you don't wind up with a lot of machines with mini-nt as their name. Okay. All right, finally, unknown and the impact of required and unattended deployments. Definitely something to be aware of, even with known. This is a topic that will largely apply to known as well. So huge caution here. Caution doesn't mean don't do this. Caution means be aware that you're getting yourself into a more risky scenario anytime you choose to deploy a task sequence as required or unattended. Right? Now, there are very valid reasons to do it and very good business cases that can be solved by doing it, but it's not something to be taken lightly and something you definitely want to have a good understanding of what you're doing before you do it, and a lot of testing that tells you that you're going to do it well and not run into problems. Okay, so unattended simply means that you don't need to have anyone in attendance when this task sequence runs. Frankly, unattended to me is the nirvana of imaging, so that you don't have to task technicians with watching over the imaging process, and you don't have to have anyone there to answer dialog boxes and that kind of thing. It's where you want to get to, I would think, as an OSD admin. It's not where you start. There's a lot of learning that has to take place to get you there, but it is where you want to be. Right? Required, if you're going to do an unattended deployment, it can't be unattended unless you have that deployment being required. Well, that's not true. There's some other ways to do it too, but for the most part, if you're going to do an unattended install, you're going to have a required deployment, right? So a couple of things with required. Again, this applies to known and unknown. There will be some things that are unique to known I'll mention in a minute. For a required deployment, if you're going to use those, only use one of them per collection, or even better said, only use one required deployment per system that you're targeting. So in unknown, that means one required deployment per, if you want to split it down this far, per site and per architecture at that site. So at a single site, say that you have a hierarchy with a CAS and two primaries. In that scenario, you could have 4 different required deployments, required task sequences, one for the x86 and one for the x64 at site A, and another for the x86 and x64 at site B. You could go that far. That's as far as you can go, though, right? If it's going to be required, if you have more than that, so say that you wanted to put more than one required in one on one machine. I've seen that. We don't stop. We pick the one that we think should be run, the first one we come to, and we take off and we run, right? You don't want more than one required task sequence targeting a given machine, right? However you do that, okay? Here's another thing, kind of unique to unknown systems. Unique to unknown systems, particularly whenever you have Pixie in the picture, right? Whenever you're doing a Pixie boot. If you have an unattended and by default required task sequence that you're targeting to unknown computers and you're allowing Pixie boot, you have just increased your surface of potential problem many fold, potentially affecting every computer in the environment. Probably not, right? But if the computers in the environment, whether they have an operating system or not, are configured to Pixie boot first in their BIOS boot order, those machines are going to Pixie boot and they are going to start imaging, and it's not going to stop. Once you start imaging, you've pretty much lost that computer. And that's not a good situation to find yourself in. So that's why be very careful. That's why if you're going to do this kind of thing, required unattend, known is a lot better situation for you, right? Because if a system's not in the ConfigMgr database, it won't be able to image. You can still do a lot of damage with it being in the ConfigMgr database. Unknown even opens it up more, right? All right, and that kind of leads into the next topic, security concerns. So if you have unknown turned on and you're going to allow Pixie booting, then very literally, any person who wanted to, has the knowledge about it, could come into your environment if you let them in somehow, if they get in, right? Or access your network or whatever, Pixie boot a machine, get one of your images and walk out, right? I don't know if that's ever happened. I don't know how likely it would be, right? But it is at least a possibility that you want to think about before you turn on unknown computer support. One other thing, I could list out several different things beyond this, but one other thing was software updates. So when you're doing software updating in a task sequence, there's two ways you can do it. The first way is the one that's built into to OSD called install software updates, and that requires that your system be in a collection where updates are targeted that apply to it. So in this case, the software updates would need to be targeted to all unknown computers, or ultimately the computer object, right? That's a limitation. If you don't want that limitation, or just have a preference like I do for another way to install software updates, you can use the install software updates offline, which doesn't have this limitation. That happens while you're in PE. So it's actually better in my mind for a number of reasons. Okay, that said, let's pull the lab back in, and I'm going to do another quick demo here. So what I wanted to show you is the unknown computer boot process. So what I have, let me find it here. I have a bare metal machine that is not known. You can see all of my known computers here, right? There's no record of this machine. I could be faking you out by the names of, all systems. You want to see all systems, don't you? Okay. So I could be faking you out by the name at which I'm using. Here's an unknown record from previous work. Let me just go ahead and delete it. Okay. So I could be faking and renaming one of my records, but I'm not. And there's no indication of this machine anywhere in the database, right? What I do have, though, if I look at all unknown computers, look at properties, you will see that I have a deployment of this Windows 8 task sequence. Okay. If I look at the Windows 8 task sequence, right here, you will see that the only deployment I have is to all unknown computers in this Pixie Boot demo. I'll actually get rid of it just to clear any question. All right. So now only to all unknown computers. So that said, I'm going to go ahead and start my machine. So go ahead and start it up. I'm going to boot this thing, not Pixie, but from an ISO, and let it come on up. Here we come. Our friend is F8, so I'll go ahead and press that. And we're ready, so I'll go ahead and click Next. We'll go out and find the task sequence. There it is. We know that came through unknown computers because it's a task sequence not targeted anywhere else, but I can prove that through the logs too. So if I go to the logs, our friend Notepad, and all I'm going to do is I'm going to search this log for unknown. All right. So the first hit I get just simply comes down here to the variable. It's an internal variable that basically says either this task sequence supports unknown or it doesn't. Don't see the value here, but if I search again, I'll see really quickly support unknown machines equals 1, which means true. All right, search it again. And now I say, or I see an entry that says these are the potential unknown machine GUIDs, not saying which one will be used right now, but these are at least the potential ones. And you'll see that there are two here. There's this one, and there's this one, right? So I'll go into that more in a minute. We'll progress, right? So here I see that I've got an x86 one, an x64 one, move on down, and finally I decide that I am going to use this unknown machine GUID. Now why did I decide to use that? Well, if we go back up a little bit, we'll see that we're going to execute a request for the client. So the very first thing we want to do, well, one of the very first things we want to do is find out if this system that we're trying to boot is actually one that's in the ConfigMgr database, because we're going to stop there and look at any record that matches. We're going to treat that preferentially to unknown computers and try to find the task sequence on that. If there is no task sequence on a record that matches, then we're going to give up. We're not going to flip over to unknown computers if there's a record in the database. So we're going to execute the identity request, requesting the identity. Here we're going to talk to the management point. Request was successful. Here we get back our response, and you'll see the client identity is blank. This one, you'll see the NetBIOS name is blank. Then a summary, and the state is known, which is kind of misleading because the state actually is unknown. If it was known, it would have a client GUID and a NetBIOS name. But since we don't, and unknown computer support is allowed, we're going to leverage the GUID for unknown computer support. How do we know which one to use? I'm going to go ahead and back out of this machine at this stage. How do we know which one to use? The way we know is because over here, again, in all unknown computers, I have my architectures, and I see, was it that one? Maybe it's this one. Yeah, here. This is the GUID we saw, and this is the GUID that matches an unknown computer record for the site where this machine booted. Right now, that's important. So let me show you. Let me show you that as well. So to do that, I'm going to pull in another lab. We're going to do this boot a little bit differently. So let me drop this over. Here's my other lab. Pull that in. Log in real quick. All right, so I have here, let me set this up a little bit differently. So here in my assets and compliance, I have the same kind of structure. I have multiple sites. Collection, sorry. So I have my all unknown computers collection. I'm going to show members. And I have the same records in my database. I've got a one for, I used to have a site PS3, it's gone now, that didn't clean out, so that doesn't exist anymore. But I've got an x64, one for PS1 and one for PS2, two x64 records, and two x86 records, one for PS2, one for PS1. So I mentioned that you can absolutely treat unknown computers differently at the site level, right? There's only two objects at the site level, one x86 and one x64. So you can have two separate deployments for x64 and x86, right? And we will pick appropriately. So I want to show you that. The first thing that I want to show you is a machine booting to a site PS1, then the other one PS2, and I'll show you. All right, so let me go up here. Here's my bare metal system. So let me just look at the settings on it real quick. So here you will see that I've got boot media. I have PS2 there. Let me just do PS1s to keep in order. So here's boot media that I created at PS1. Better said, I created boot media and chose a management point from PS1. Okay? So if I boot this machine, and I won't have any task sequences here, it'll actually fail, but I don't really care about that right now because it'll go through the motions far enough. So I'll boot this machine. It'll load up the boot media. I'll click next, and then we'll look at the logs. All right, so there we are. Now let me just hit next, and we're going to fail, and I'm going to hit F8, right? And the same kind of thing, except here I just want to show you some things. Unknown. All right, same pattern that we were seeing before. Except here, notice that we're going to have two potential matches given to us. This GUID and this GUID, right? So remember that. There's a 333 and a 7E3. So if we go over to our site server and look, this is PS1. So I'm going to look at the x64 record for PS1. And here is, did I get PS1? Yeah. So here is the 4B14. If I look at the x86 for PS1, one moment, that doesn't line up. I might have done something wrong. Stand by. Let me go back here. Okay, so 7E3, 333. Make sure I have that right. I might have done the wrong boot media. Okay. Okay, there's 7E3. I might have done the wrong boot media. 7E3, and then the corresponding x64 for PS2 is the 333. Okay, there it is. So yeah, I did the wrong boot media. I'll switch that around in a second. And so if we continue on in our VM, we'll see the next entry is us selecting 333, and well, and off we go. Right, there we are. So 333 is selected, off we go, and that's where we are. Okay. So no, even though we have multiple unknown records, since we chose the management point at specifically, in this case, even though I didn't mean to, the PS2 site, we are limited in scope to just those unknown records, right? This applies regardless of the way you do your media. It really depends on the management points you're talking to, right? Even if you have dynamic media instead of static, we'll choose the right management point through that process, assuming boundaries are correct in the case of dynamic media, and you'll see the same kind of thing. All right, so let's turn this off and try this again. So go in here to settings and DVD. Yeah, look at that. See? PS2. I thought I changed that. Whatever. I will make sure it's gone this time. And now I'll browse to PS1. Maybe I put it on the C drive. Yeah, there it is, ps1.iso. So you already know what you're going to see, but I'll do it anyway. So hit OK, turn this on, action start. Let it boot up. And this time you'll see that we're selectively choosing the unknown records from PS1. And F8. Next and fail, that's fine. Here. Same thing, search for unknown. There it is, find next. Oops. Up. There, same thing. All right, cool. So this time the GUIDs are different. Here's A7 whatever, and then 4B1, right? And so if I look back at the site, I will see, now that I know it's PS1 that I'm booting to, so for the x64, I see 4B1, And for x86, I see, if I choose the right record, A78, right? So that lines up, hopefully demonstrates kind of the selection process we use when going through this. All right. All right, so before we leave this, a couple of things I just want to loop back to that I didn't mention, I think are important to mention. So I mentioned the whole computer naming thing, and using the OSD computer variable, mentioned that there are a couple of ways that you could actually set this so that you get a predicted name instead of mini and t. So you can certainly set it, you could set it as a variable on either the custom collection, all unknown computers collection, or on the unknown object itself. That is incredibly limited because every system that would boot and try to image would then get that name. So that would be very confusing. Could do it. Better ways would be through script, through an HTA, right? So if I pull in the lab again just to show, let me just get there real quick. Go up software library, go through task sequence, create task sequence media. Bear with me for a minute while I work through this to get to the end. Don't really care about that. Okay. Again, boom, boom. Don't care. Here, I'm going to just pick something. And then here's where I select my management point for this media so it knows where to go. Here. So here with the enable pre-start command, you could do something in here. You could even, there's even a way on the boot media itself to have a pre-start, the boot image itself to have a pre-start command, or you could do it here if you don't want to put it on the boot media itself or boot image itself. But here the point is, with the pre-start command, you could write a script. I mean, literally, you could write a script, depending on your environment, in a pre-start command that would allow you to boot in an unknown scenario and then read details from your environment, from some place on the network, from wherever you might want, and pre-populate a whole slew of variables that will cause the imaging experience of this system to be different, almost like a known type of scenario, that kind of flexibility, right? There would be some caveats to it, some delays that you'd have to deal with as potentially, right? One of the things you can assign is OSD Computer Name through there, right? Another way you could do it is launch an HTA from here that will allow a user to type in the name of the computer, save that off, populate the OSD Computer Name with it, and off you go. The downside of that, if you're trying to be zero touch, you're defeating the purpose because now someone has to supply that information, right? There's other ways you could do it. You could actually have a web page. There's one example of that on my blog, where you would have a technician sit at their desk and supply the information, hit submit, and now maybe it would write itself to a file somewhere on the network unique to this machine that this machine could read and populate the variables. Lots of ways. Great amount of flexibility in OSD. That's why it's so cool, right? So I wanted to cover that. Then the other thing that I wanted to hit is talking about the security issues with required, with Pixie booting, with unattended, that kind of thing, right? There are some ways to mitigate those things, probably more than this maybe, but certainly to mitigate those kind of scenarios, you could set a password on your media, on your Pixie boot, right? Now that also means that someone has to be there in order to answer that password. You're really not able to do a required deployment then so much, an unattended deployment then, because you're going to have to stop and answer the password and kind of things, right? You can still do it, but you get the idea. It kind of takes away from the zero touch. You could set Pixie Boot, make sure Pixie Boot is not the first option in BIOS, right? When it is, that can add to challenges and exposure. You can use, we talked in the Pixie Boot session, how you can set a WDS registry key to exclude those sensitive systems that you just want to protect, right? Could be executives, could be your whatever class of systems that are really, really important to your business and would be crippling if they were to go down. All right. So that said, let's spend some time. We'll speed through this a little bit quicker than the previous discussion. Let's talk about working with known systems. All right. So known systems, to me, that's really the nirvana of imaging. This gives you the greatest flexibility, gives you the greatest control, right? So we talked about with unknown that you're really limited. You can only really have 2 task sequences deployed per site, one to x86, one to x64. Most of the time people do them just one task sequence to the unknown computers, or maybe multiple that then a technician chooses from, whatever. Here you have a lot greater flexibility because you can target whatever specific object you want. If you have a Windows 8 task sequence, a Windows 7 task sequence, a 2012 server task sequence, a 2008 R2 server task sequence, whatever, right? You could have a collection for the Windows 7 and target just the Windows 7 to the objects that happen to make their way into that collection. Same for Windows 8, same for 2012, same for 2008 R2. 4 collections, the objects that make their way in and out of those collections could be different, whatever, right? So a little, not just a little, a lot more control, flexibility-wise, over how you could target. Beyond that, there's also a significant amount more control over the variables because you can assign them directly to those unique collections. You can assign them directly to the systems that are in those collections, right? So good stuff there. So honestly, this is something that requires pretty good understanding of OSD. I've always described OSD as kind of like layers of an onion. You start with the onion, think it's pretty cool, pull a layer back, find out there's another layer, then there's another layer, then there's another layer. OSD is the same way. You can get started with it really pretty quickly, but then if you really dig deep into it, you start to realize some of the flexibility and the power of OSD. In my experience, folks that kind of go the unknown route stop their learning a little bit, not really intentionally, but they're doing unknown, and so they don't get exposed to some of these other possibilities that are out there. And once you see these possibilities, it really is pretty cool, right? It does require enhanced skills. It does require enhanced understanding. It's very common for folks to start easy and grow deeper. Start maybe with unknown and move to known. Very reasonable approach. Just encourage you to take a look at known if you have never done it because of the options it gives you. So how do you actually go about making a system known, right? Well, we have the import wizard, so let's pull the lab back in. Pretty simple, right? So we can go to our assets and compliance devices and import a computer. We can import using a file. So if you have an arrangement with your manufacturer where they provide you a list of all of the MAC addresses for the various computers you're going to get, put them in a spreadsheet, you can import those pretty easily. You can even do automation to do that if you wanted to, and if it worked for you. Or you can do single computer import, which gets to be a little bit tedious to do manually. What we need for that is simply the computer name and one of these two, not both, MAC address or SMBIOS GUID. Right? Once we have those, then that's what we can uniquely use to identify the machine. I've already implied it several times. If you haven't heard me and understood it that way, I'll say it directly. When we boot up a machine to try to acquire the task sequences targeted to it, the way we search the database for our machine is we first look for a match. I think the first one is actually SMBIOS GUID. We look for a match on SMBIOS GUID, and if we find a match, we stop and we evaluate whether the object we've found has any task sequences deployed to it, and then we go from there. If we don't find a match on SMBIOS, we then switch to MAC address, and if we find a match there, then we stop processing and find out if there's any task sequences targeted to that object. If there are, cool. If not, we end, right? If we have found a known object, either by MAC address or SMBIOS GUID, even if there's no task sequences that come up as targeted to us, we don't ever try unknown. It's only when we don't have a match on Mac or SMBIOS that we will fall over and try to leverage unknown, right? All right, so you can use the wizard. I would encourage you to do so just to get familiar with importing. But in production, it isn't really something that you might want to do. So one of the reasons people shy away from known is because of this thing. You have to get these machines into the database if they're not there already. And it's seen maybe as a little bit of a tedious thing because of this wizard, and so it doesn't have to be, right? So I showed you this pre-start command on the boot media. We also have the pre-start command as mentioned on the boot image, right? However you want to do it, there's different ways that you could, right? You could go through the entire process of making a machine, import it into the database, shift it over into the collections and all of that before you ever start. Huge tangent here on the side. I could show you this, but since I don't have it set up, I'll just talk you through it. So let me actually boot one of my machines again for a second, and I'll show you. So I'm going to boot this one, bare metal. Okay. So we're going to load the PE media. This is what I'm going to show you is helpful to know just in general. So we're booting PE. It's going to come up, and then I'm going to click Next. Well, not yet. All right, here. So I'm at this screen, right? When I click Next, we're going to then come up with a screen that shows me what task sequences I have available, because mine are available, not required. If it was required, I would go and do it. You know, if this were set to allow unattend, which you can do on boot media, by the way. I may not have shown you that. Let me show you that real quick. On boot media, you can absolutely set unattend as well. So create task sequence media. Here is this option that you can tell boot media even to run unattended if there's something out there that's required. Right? So if this were required, I just wouldn't even stop at this window. I would run forward. But I don't have anything required here, so I'm going to click Next, and then I'm going to stop at this next window. What happened, though, behind the scenes between those two items? I could even dig in the logs and show it to you, but for interest of time, I won't. Before we ever hit the network the first time, before we ever hit ConfigMgr the first time, we execute the pre-start command. So knowing that, it would be very possible to take write a script that takes the information about this machine. Maybe it discovers a computer name from somewhere that you've prepared for this machine, and it on the fly imports itself into ConfigMgr. So you might be thinking you're booting this thing unknown, right? We haven't gotten to that point yet. We haven't gotten to where we're trying to decide known or unknown. We're just booting, right? And whenever we click that button from the previous screen to this one, we're running that pre-start command. We can import the machine then programmatically. And not only that, we could actually take that machine, and if we know what it needs to be, again, through whatever magic you might do, feeding data to it through a file or whatever, network, gateway, whatever it is you're looking at, if you know what that machine needs to be imaged as, then you can make sure the computer object gets into the right collection where the task sequence that you need is targeted. Now we're known because we've imported, we've put ourselves over a collection. You can even add variables to that machine on the fly, right? And once we get done with our pre-start, which could take several minutes for sure, once we get done with our pre-start, then we release, and then we proceed with normal OSD processing, which at that point we would make an identity request first, and because we've done all that pre-work, now we're known, and we would do whatever needs to be done, right? I know that's a lot to maybe digest in this setting, but pretty powerful stuff. Other things that you could do, that one that I just mentioned, you could do, and it would still put you in the arena of zero touch. You could pop up an HTA. That would be light touch for sure, and let people enter information. Some information, enter it manually. Maybe you discover the MAC address and name, through a combination of looking on the, configuration of the machine and whatever inputs put in, whatever, right? And put that in. You could also do that web page and feed that information to the computer, maybe through the pre-start command, whatever, right? The sky really is pretty much the limit. There's so much flexibility here to make a system known, right? Planning for computer names, moving right along. Now, the real difference here is when you're using known computers to do a reimage, right? We talked about how unknown can only ever be done from bare metal. in order to do a reimage, it has to be a known system. So if it's a known system and we start from the OS of a known system, then the task sequence, if it's configured using the defaults, will go through and capture the Windows settings. So that would include computer names or other things optionally that you might choose. There's a checkbox to include certain other things in there. I forget what they are right now. But it would capture computer name, store that away in the OSD computer name variable, and then preserve that. Once we get the new image laid down, rebooted into it, we would give it the computer name that it started with. Right? If you don't have to do that, you could choose to do something different. While we're in PE, the name is mini-nt, as I recall. I have to check that to be sure, but I'm pretty sure even in a reimage scenario, it's mini-nt, right? So, whatever. Again, it's kind of knowing what the system does, how it does it, where it does it, to help you make the decision about how you do these things, right? In this case, planning for computer names. So the whole idea of known systems and required and unattended deployments, largely the same set of things that we've already talked about. Again, the challenge here is an unattended deployment will just go. Don't be nervous about that. Works very well with automation, right? The key thing here is that if you're using a known machine, it's safer, because unless that machine is known in the ConfigMgr database and has a task sequence applied to it, you can boot all day and it's just going to say, nope, sorry, goodbye, right? So that reduces your potential affected surface substantially. Just make sure you don't put a required task sequence to the all systems collection, right? And it certainly reduces the risk of someone having a machine and plugging into your network and obtaining one of your images because you have unknown computer support turned on, right? Okay. Now, so software updates, same kind of thing. You don't really probably have to worry about it here because your deployments very likely will already include these machines and such. And so software updates, that step we were talking about for unknown, should mostly just work, but be aware of that too. All right, so already went through this demo. I showed you how before we ever got to the unknown in the boot process, we first do that client identity request, make sure we can try to match against existing clients and that kind of thing. So I won't repeat it here. I'll just move on. Okay, the only point of this slide. So it is technically possible to support both known scenarios and unknown scenarios. Really would encourage not to do that. Not that it's not possible, but it does add levels of confusion. Talking about those scenarios where we have an unknown machine that we image, and then we become known through the imaging process. Well, if we ever have to try to image that machine again, through unknown, we're going to have to make it unknown, and so on. So it adds some confusion, right? Can be done safely. Absolutely, it can be done safely, but certainly something that if you don't have to have the confusion in the mix, better not to. So would recommend pick one, whichever one you want and fits for your environment, and then work with that. All right, a couple of things real quick, and then we'll wrap up. So what are the benefits of using unknown? What are the challenges of using unknown? Well, first, it is true that using unknown does reduce the administrative workload, kind of, right? It might. It's easier to get set up and implemented for sure, but there can be some little things about it that can actually increase the workload somewhat. But generally, it's seen as being a quicker pathway to imaging, and for that reason, it's the way most people start. That's good. No problem there, right? No computer import required, and so on. It's a simplified approach for sure to imaging, and that's good, right? Because OSD is a big beast, and learning it takes time, and working well with it takes time. So getting started simple, and then adding the layers to understand the complexity is a reasonable approach, and one that many people take. I just would encourage you to make sure you don't stop with the simplified approach and really get into it to understand what all it can bring to you. Third one is it's often viewed as good enough, right? It's good enough. We get our imaging done, it meets our needs, and so on. If that's the case for you, that's great, right? Still good to know about the other options, but if it's good enough, then that's cool. There are some challenges with it. We've already run through these, so I won't really belabor the point a whole lot. Less specific security. We talked about that scenario of someone coming in, plugging in, whatever. Again, don't know how often that would happen or how much of a risk it really is, but it is there. Flexibility. Talked about the limitations with collections and the number of unknown objects and so on. Really only a single device per architecture per site. Already been through that, right? Talked about the ways we can use the pre-start commands and scripts and so on to even work around that, though. But that does get to more sophisticated imaging, which I think is a good thing, right? It's where you see some of the power. Some of the challenges, another challenge, sorry, is what if the system is known, right? So that whole churn that I showed in the previous slide, it starts off unknown, then it becomes known, now it goes back to unknown, right? And some of the just, oh, I forgot to delete it from the database before I re-imaged it kind of thing, right? If it is known, we're never going to get to the imaging through unknown. The Pixie database flag thing is really not specific to unknown. It's just a challenge for any kind of imaging. Certainly it can be a challenge for unknown as well. Really, though, it applies very minimally here and mostly to known. So that could be a bridge point to talk about known. Let me show you what I'm talking about. So if you have a deployment, a task sequence deployment to a machine that is required, and that machine Pixie boots to initiate that image, then and it has to be required. You see that here on the dialog. When we do that, we're going to put a flag in the database that says, hey, this machine just did a Pixie boot, and it was a required Pixie boot. So don't let it Pixie boot again until manual action is taken to clear that field. Why? Because in many cases that I've come across, the BIOS boot order is set Pixie first. If we did not set this flag and we had a required deployment, that machine, every time it rebooted, would image. Right? Definitely not something we want. So again, just applies to required, not available. And so, manipulating this thing can be an interesting situation. There is a scenario, mostly not seen on the workstation side, more seen on the server side, where we're using the toolkits provided by the various OEMs to configure hardware. But there's a place in which if we might need to configure the hardware in that case, or do something else maybe, reboot and initiate the imaging process from the start once the hardware is configured. You can't do that because of this flag. There's actually a step called reboot to Pixie that are in these toolkits provided by the manufacturer that will programmatically go and clear this flag. It's really just a VB script, as I recall, but something that could be an interesting tool in your tool belt if you need it, so you can go find those toolkits and install them and look at them or whatever. All right, so let's pull this back out and switch over. So what about the benefits and challenges of known? Right? Certainly the benefit, very flexible, been through that, right? Security, not as much of an attack surface, really limits it a lot, or an exposure surface, not attack, really limits it a lot, right? There can be challenges and such, because in this scenario, we're specific. You can run into this in unknown, frankly, too, right? Because I mentioned if we do find a match on a Mac or SMBIOS GUID, I say UUID, I should have put SMBIOS. If we find a match, then we stop. We will never unknown boot this machine because we think we found a valid record. So it has an impact. There has an impact here too, right? A couple of scenarios. You want to try to avoid, as much as you can, duplicated MAC addresses, duplicated SMBIOS GUIDs. I've seen scenarios where they are duplicated. Very good example, not exactly a problem so much for OSD, but a good example of it. Years ago, we had a dial-up adapter in our OSs. We have equivalents in the more modern OSs. In some cases, you can snap in. They have a MAC address. And since we had so many of them on systems across the enterprise, if you look in the database, every system had the same MAC address. Had more than one MAC address, one for its actual NIC and another for the dial-up adapter, right? So you'd have a ton of duplicated MACs. I'll see that today for various reasons, seen it with VMware and so on. And that can be problematic. You're not going to really boot for imaging with your dial-up adapter, right? So not so much of a challenge from that perspective. The dial-up adapter all have the same MAC address, so probably not a blocker there, but interesting to understand and illustrate the point. Where we do see a lot of interesting things today is we live in a world where everyone has a tablet, it seems like, right? Tablets are really, really cool things. They are very thin, they're very lightweight, very capable, right? One of the challenges with tablets and imaging is while you're imaging, you want to plug into a network cord, right? So you get best imaging performance. So that can either be done through a docking station or even a dongle, an Ethernet dongle, right? Both scenarios kind of have the same challenge. So whether you're in a docking station, maybe you have a 3 or 4 docking stations that you randomly use for imaging, 20, 30 tablets at a time. Or you have an Ethernet dongle that you keep moving between machines, or a set of them keep moving between machines. Here's the problem. For the first one that uses that dongle, that's great because there will only be one record in the database if you choose known, or there won't be any records in the database if you go unknown, and so that machine images. The next machine that you try to boot with that dongle, though, especially if you've had enough time between the first machine and the second for the client to do hardware inventory, which you probably have, then we will have that record of the dongle MAC address tied to the first machine in the database. So guess what? When you try to boot the second machine, we find a record. If you're in unknown computer support and you're expecting to image that way, it's not going to happen because we've just matched a machine that exists, and so we're going to stop. Now, if that existing machine has a task sequence targeted to it, which probably it doesn't because it just got imaged, then we'll be fine. But things to be aware of, right? So that's really it. Wanted to go through the whole concept of known versus unknown. There's probably some other things that we could have added in, but hopefully a good enough discussion to illustrate the point. So we will end here and pick up in session 14 soon.